Okay, we've seen that substitution is an accurate method for solving a system of linear equations. Well, another accurate method is the addition or elimination method. The addition method, it's based on the addition property of equality, which is adding equal quantities to both sides of an equation does not change the solution of the equation. All right, so to see how we use this to solve a system of equations, let's solve the system x plus y equals 7, x minus y equals 5. Okay, well, since the left side of each equation is equal to its right side, we're adding equal quantities when we add the left sides of the equation together and add the right sides of the equation together. Well, this adding eliminates the variable y, and it gives us an equation in one variable x. We can then solve for x, okay? So again, we're going to add the right sides of the equation together and add the left sides of the equation together, okay? So we're going to add the left side together, and then we're going to add the right side together. All right, so x plus x is 2x. Y minus y is 0. 7 plus 5 is 12. All right, so we've eliminated y. All right, so now to get x all by itself, we have to undo multiplication because it's being multiplied by 2 at this point. And the opposite of multiplication is division. Okay, so x is 6. Okay, so the x value of the solution is 6. So to find the corresponding y value, we let x equal 6 in either equation of the system. So we'll just use the first equation. Okay, so x plus y is 7, so we're going to let x be 6. We're going to try and get y all by itself, so right now 6 is being added to it. To undo addition, we're going to subtract 6 from both sides. 7 minus 6 is 1. All right, so the solution is 6 and 1. All right, so let's check the solution in both equations of the original system. Okay, we'll do that up here. So 6 plus 1 is 7. 7 equals 7. Yep, so that's true. Okay, so let's do the second equation. 6 minus 1 is 5. 5 equals 5. Perfect. All right. So the solution checks out. All right, so let's, if we graph the two equations in the system, we're going to have two lines that intersect at that point, 6, 1, okay, that coordinate. So let's go ahead and look at that and see what it looks like. All right, so the red line we have, the red line is x plus y is 7, and then the blue line is x minus y is 5, and as you can see, they intersect at the point 6, 1. Okay, let's do one more. All right. So before attempting this one, we just want to make sure that we use what we know to make this system as easy as possible to solve, all right? So we want to just get rid of these fractions, right? So to do so, we're going to multiply both sides of the first equation by the lowest common denominator, 2, and then both sides of the equation by the lowest common denominator, 6, all right? So let's go ahead and do that. All right, so we're going to take this first one. We'll just reuse this here. And we're going to multiply it by 2. And remember, what you do to one side, you have to do to the other side to keep it in balance. Okay? And then we're going to multiply this side by 6. Again, remember, what you do to one side, you have to do to the other side. Okay, so this simplifies to minus 2x minus y equals 5. And this one simplifies to x minus 3y is 0. All right. We can now eliminate the variable x by multiplying the second equation by 2. All right, so let me rewrite it down here. We have 2x minus y is is 5, and we have x minus 3y is 0. And we're going to multiply the second equation by 2. So let's do that. Which is going to simplify. This stays the same, and then this one simplifies to 2x minus 6y is 0. All right. Now let's add the equations. So the x's go away because minus 2x plus 2x is 0. Okay? And then we're going to have minus y plus minus 6y is minus 7y. And 5 and 0 is 5. And we're trying to get y all by itself, so it's being multiplied by minus 7. Undo multiplication, we're going to divide. So we're going to do that to both sides to keep our equation in balance. So y equals minus 5, 7. All right, so to find x, we could replace y with minus 5 sevenths in one of the equations with two variables. All right, so instead, let's go back to the simplified system and multiply by appropriate factors to eliminate the variable y and solve for x. So to do this, we multiply the first equation by minus 3, okay? So then the system's going to be, I'm going to go ahead and clear this out, and then we'll do that. So minus 3 minus 2x minus y. Okay, so this is going to simplify to all right, so check the ordered pair, right? Minus 15 sevens and minus 5 sevens. Minus 15 over 7 for x and minus 5 over 7 for y. Alright, so to solve a system of two linear equations by the addition method, the first step is to rewrite each equation in standard form. And then for step 2, then, if necessary, multiply one or both equations by a non-zero number so that the coefficients of a chosen variable in the system are opposites. Then step 3, add the equations. Step 4, find the value of one variable by solving the resulting equation from step 3. And then step 5, find the value of the second variable by substituting the value found in step 4 into either of the original equations. And then step 6, check the proposed solution in the original system. All right, well that concludes this video.